In this video we have two integrals to evaluate. They both involve the exponential e, and the technique we're going to use is kind of related. If you don't see which approach to use, whether it's partial fractions, we don't have rational expressions here, integration by parts, trigonometric substitution, if it's not obvious, look for U-substitution. So U can be what? Well, e to the x here, we take the derivative of e to the x, it won't give us something in the numerator where we can replace it. Now sometimes you might have to multiply the numerator and denominator by something. Sometimes it could be the conjugate of the denominator, especially if it involves a radical expression. Now in this case what I'm going to do is I'm going to multiply the numerator and the denominator by e to the minus x. Because notice here, if I let u equal 1 plus e to the x, the derivative doesn't give me something I can replace in the numerator. So I'm multiplying by e to the minus x, numerator and denominator. This will give me an e to the minus x, the numerator. Then here it'll be e to the minus x times 1 is e to the minus x. And e to the minus x times e to the x is 1, because that gives me e to the 0. This will be a dx here. So now, what happens if I let u equal to e to the minus x plus 1? Then du would equal to derivative of e to the minus x is e to the minus x. And then we multiply by the derivative of minus x, which is the exponent. We have minus here, or minus 1. Derivative of 1 is 0. This will be dx. And let's multiply both sides by negative 1 here. I get minus du would equal to, and then negative times the right side just gives me e to the minus x dx. Now we can apply the U-substitution here. Notice e to the minus x dx here, that's in the numerator. So I can replace this product e to the minus x dx by a minus du. I put the minus out in front here. And of course the e to the minus x plus 1 in the denominator, that's your u over here. So this will be a u. And of course we know the formula for the integral of du over u, or 1 over u du. This will be a minus here. That's just the natural log of the absolute value of u, which is this right here. But e to the minus x plus 1 can never be negative. It's always positive. Because e is positive, doesn't matter what the exponent is, that's going to be positive. And you got a plus 1. So I don't need absolute values here. This would just be natural log e to the minus x plus 1 plus a constant of integration. And that is your solution for this one. Now for the next one, the same way, if I let u equal to what's in the denominator, that won't work. So let's try the same thing here. I'm going to multiply by e to the minus x in the numerator and e to the minus x in the denominator. So let's see what we get here. So e to the minus x times e to the 2x at the exponent, so that'll be e to the x. And this will be minus e to the minus x times the minus 1 here, of course, gives me minus e to the minus x. And the denominator, again multiplying through e to 2x times e to the minus x, adding the exponents out of just e to the x, and then it's plus 1 times e to the minus x, e to the minus x dx. So now let's let u, let's try it again. Let's let u equal to what we have in the denominator. e to the x plus e to the minus x. And du, when you go to the derivative of that, derivative of e to the x is just e to the x. Derivative of e to the minus x is e to the minus x. But I got to take the derivative of the exponent. Now you can do it over for the first one, but the derivative of x is 1, so it doesn't affect it. But it's negative, this will be a minus here. So we'll get that. And this will be dx. So now look at the numerator. Look at this as the product. E to the x minus e to the minus x dx, that's this expression right here, which is du. So now this is just going to equal to the integral. Can replace this expression in the numerator by du. And the denominator, e to the x plus e to the minus x, that's just du. So that's equal to, again, 1 over u du, or du over u. That's just the natural log for the integral of absolute u. But again, e to the x plus e to the minus x is never going to be a negative, so I don't need absolute values in this one. That'll just be natural log of e to the x plus e to the minus x. We have plus the constant of integration. So ln parentheses e to the x plus e to the minus x. That's your answer. Thanks for watching. We'll see you next time.